Welcome again to Nikki's Dad Discusses Physics. So, when I was helping Nikki with her homework the other day, we came across a problem that involved a uniformly or constantly accelerating object, I think it was a car, going from initial velocity, accelerating for a certain amount of time, and the question was, what is the distance covered? Common problem in kinematics and motion of objects, and one that's quite interesting for the physics students. So in this case, the challenge becomes one of determining, what happens when the car accelerates. How do you figure out that distance? Well, many physics students are given a simple equation for this. It's d equals 1/2 at squared plus vit. And so I had a look at Nikki's formula sheet, and that equation wasn't on there, which is quite interesting. So, we just plugged in the equation and solved it and got the answer. But it led to an interesting discussion. Where did this equation come from? And so I want to talk about that because it's very important as physics people and interested scientists. Where do these equations come from? How are they derived? And this is an interesting one because to be a good mathematician or a good physicist, you always want to be able to understand things from first principles. And in this case, it all goes back to the idea that any motion in an accelerated system can be described as a same motion considering some kind of average velocity. So if you drive your car from A to B and you speed up and you slow down, and you change your motion multiple times, you can describe that exact same trip as if you traveled at some average velocity constantly. So that's basically what you have to do to solve this. So if you want to figure out how much distance has been covered when you started at some initial velocity, accelerated for a certain amount of time, and at the end of that time, how much distance is covered, you really need to figure out, well, what was my average velocity during that time? Because then I just know that d equals v average times t. Simple enough. The trick is, what is the average velocity? Well, the average velocity is simple to figure out. It's the initial velocity plus the final velocity divided by 2. Just like you find any average. If you're adding two numbers together, divide by 2, and that'll give you the average. So our equation now goes from d equals v average times t, now becomes d equals v initial plus v final over 2 in brackets times the time. Okay, we know vi. Problem is we don't know vf. What is the final velocity if an object constantly accelerated for a certain amount of time? Well, for that, we need to know what the change in velocity was. Well, the change in velocity is equal to the acceleration times time. Assuming it was constant acceleration, that will be your change in velocity. But don't forget, you had an initial velocity. So the final velocity is going to be vi, initial velocity, plus at. So now our equation for distance becomes, in brackets, vi plus at all over 2, in brackets, times time. Okay, vi plus vi we can simply simplify and write down as 2vi plus at all over 2 in brackets times t. Now, on the vi side, the 2's cancel. So I'm left with vi plus 1/2 at. And when I distribute my t into the brackets, I get vit plus 1/2 at squared. And normally in physics and mathematics, we write from the highest power to the lowest power. So I just, order of operations for addition. I can change the property, associative property, I think. I forget my properties. I'll have to look that up. So anyways, I can flip it. So I can write it from highest to lowest power. So 1/2 at squared plus vit, and that gives you your distance. Well, maybe it's easier just to remember the formula, but it's always good to know where it was derived from. I hope this helps you do better at your physics and better in your tests. So next time Nikki has a problem, I might talk about it again. Bye for now.